Hey everyone, and welcome to a deep dive into one of the most complex and fascinating things out there, the human brain.
I'm really excited to be here.
We're going to be drawing on insights from V.S. Ramachandran's book, The Telltale Brain, for this duck dive.
Ah, that's a great choice. It's full of mind-blowing ideas.
It really is.
Yeah.
So we're kind of like having a direct conversation with a leading expert in the field, offering a shortcut to a deeper understanding of ourselves.
Yeah, it's like a backstage pass to the inner workings of our own minds.
Okay, so first things first.
hmm
What exactly makes the human brain so unique?
Well, Ramachandran kicks off his book with this almost a sense of awe. He compares the human brain to the cosmos, saying it's just as vast and mysterious.
That's a pretty powerful image.
Right, and what's so cool is that neuroscience is starting to shed light on areas that were traditionally explored by, the humanities, like art or philosophy.
I see what you mean. So, like, how we perceive beauty or grapple with ethical dilemmas
Oh.
all comes down to how our brains are wired.
Exactly.
So how did we get here? How did this 3-pound organ become capable of such incredible things?
Well, we have to consider the evolutionary journey. You know, the human brain didn't just magically appear, it evolved over millions of years. And in doing so, it repurposed existing structures to develop those unique capabilities that set us apart from other animals, like language and abstract thought.
It's fascinating how evolution tinkered with what was already there to create something entirely new.
It is. It's kind of like taking a toolbox of neural gadgets and just experimenting, building upon what you have to create something completely
Well,
different.
like feathers. They originally evolved for insulation and then, boom, they were suddenly used for flight.
Exactly. That's a perfect example. And it really makes you wonder what other hidden potential is lurking within our brains waiting to be unlocked.
So speaking of unlocking secrets, let's talk about illusions. Ramachandran argues that studying illusions can actually reveal the hidden assumptions our brains make about the world around us.
It's true. Illusions are like those glitches in the matrix, those moments where the curtain is pulled back and you see the code running behind the scenes.
Okay, I like that analogy.
Uh,
So give us an example. What kind of illusion are we talking about here?
we'll take the color mixing illusion, for instance. Where you shine a red light and a green light onto a white screen. What do you think happens?
Let me think. You get yellow right, but it's so weird because there's no actual yellow light. It's just red and green combined.
Precisely. And this demonstrates how our perception of color relies on just three types of color receptors in our eyes: red, green, and blue. Our brain basically mixes these signals to create the entire spectrum of colors.
So our brains are kind of like master chefs, blending a few basic ingredients to create a whole symphony of flavors. But in this case, it's colors.
That's a great way to put it.
And this tendency to fill in the gaps, make assumptions based on limited information, is what makes illusions so fascinating, right?
Yeah.
There's another illusion that comes to mind. It's that one with the eggs and cavities that Ramachandran shows in his book. Those shaded discs that can either look like eggs lit from one side or cavities lit from the other, but you can never see both interpretations at the same time.
Oh, yeah. Figure 2.3. That one's a classic.
It's a classic, and it just messes with your mind. It shows how our brain's assumptions about lighting can shape our perception.
Exactly. In the real world, our primary light source is the sun, so our brains are wired to interpret shadows based on that assumption.
But imagine if someone grew up on a planet with two suns. Would their brain interpret that illusion differently?
That is a fascinating question, and it speaks to the plasticity of the brain. You know how our experiences shape the way we perceive the world?
It's like our brains are constantly adapting, fine-tuning our senses based on the input we receive.
Absolutely. But even with all we've learned about perception, one big mystery remains. How does our brain actually recognize objects?
Yeah, like how do we know a face is a face and not a chair? It seems so effortless, but the neural processes behind it must be incredibly complex.
You're right, it's still a bit of a mystery. But Ramachandran suggests that exaggerating certain features, like in a caricature, actually makes a face even more recognizable.
Wait, really? So are you saying our brains have specialized neurons that respond more strongly to exaggerated features? Like a neuron that just loves a big nose?
Well, it might sound counterintuitive, but some studies actually suggest that that's precisely what happens. Researchers have found that certain neurons in monkeys, for example, fired more vigorously when shown exaggerated monkey faces.
Wow, that's so cool. It's like our brains are saying, give me the essence, the exaggerated version, and I'll know exactly what it is.
It's like our brains are masters of efficiency, filtering out the noise and focusing on the essential features.
Okay, so our brains are these incredible filtering machines. But speaking of filtering information, let's talk about synesthesia. This phenomenon where senses get all mixed up is pretty mind-boggling.
Synesthesia is wild. It's like a window into how the brain constructs our perceptions. We get this glimpse of how different sensory pathways can interact.
One of the most common forms is grapheme color synesthesia, right?
Right.
Where people see letters or numbers in specific colors.
Yeah.
Ramachandran mentions a woman named Susan who sees the number 7 as red.
Yeah. And they even tested her with different versions of the number 7, like different fonts, and she consistently saw red. It really suggests that the color perception is linked to the concept of the number, not just the visual shape.
So for her, 7 is red no matter what it looks like.
Exactly.
But how do we know if this is just her imagination or a real neurological phenomenon? How can researchers test if someone is actually experiencing synesthesia?
Well, they use what's called the pop-out effect. You know those images where a bunch of tilted lines suddenly jump out at you from a background of vertical lines? Or those red dots that just grab your attention?
Yeah, it's like they're practically vibrating on the page.
Exactly. And that pop-out effect is automatic. It happens instantly and involuntarily. Researchers found that some synesthetes actually experience a similar pop-out effect because of their associated colors. So the color really pops out for them. This indicates that their synesthesia is a genuine perceptual experience.
So they're not just remembering that 7 is red.
Yeah.
They're actually seeing it that way.
Right. It's like their brain is adding another layer of sensory information.
And Ramachandran points to a brain area called the angular gyrus as potentially being involved in this sensory blending. What is it about the angular gyrus that makes it a prime suspect?
Well, the angular gyrus seems to act as a hub for integrating information from our different senses. You know, when you see a cat, hear it purr and feel its fur. Your brain seamlessly blends these experiences, and the angular gyrus seems to play a key role.
It's like the conductor of an orchestra bringing all the different instruments together.
Perfect analogy. But with synesthesia, it's like the conductor got a little too creative, and now the violins are playing along with the smell of coffee.
I love that. It's so vivid. So could synesthesia actually be a marker for enhanced creativity?
Well, Ramachandran thinks it's possible. You know, maybe synesthetes have a greater ability to make connections between seemingly unrelated ideas to think outside the box.
That's fascinating.
There's also the Bubakiki effect, a really cool example of this cross-modal abstraction. Most people, regardless of language or culture, instinctively associate a rounded shape with the word buba and a jagged shape with kiki.
You're right. It's like there's a universal language of shapes and sounds, a connection between our senses that goes beyond words.
I know, it's pretty amazing. And this cross-modal abstraction might actually have its roots in, our primate ancestors. Think about it. To grasp a branch, a monkey has to coordinate its vision and touch, creating a link between visual and tactile maps in the brain.
So you're saying this ability to integrate visual and tactile information might have paved the way for even more complex forms of abstraction and maybe even language. Yeah.
Exactly. It's a compelling idea, isn't it? And speaking of evolutionary leaps, we should talk about mirror neurons and how they might be connected to something like autism. But I think we need to take a quick break before we dive into that.
Yeah, let's pause here and give our brains a moment to process all this amazing information. We'll be back in a flash.
Sounds good. Welcome back. We're in the midst of exploring those fascinating universal laws of aesthetics that Ramachandran lays out in his book.
Yeah, we were talking about how our brains seem to be wired for certain types of visual experiences.
Right, like the law of grouping, where our brains love it when they can successfully cluster visual elements together, and the law of peak shift, where we have this inherent preference for exaggerated stimuli.
Okay, I remember. What's the next law on the list?
What's the law of isolation? The idea that sometimes less is more.
Less is more. How does that apply to art?
Ramachandran suggests that a simple sketch can sometimes be more evocative than a super detailed image. He uses the example of Nadia, an autistic child whose drawings were incredibly expressive, especially considering her developmental challenges.
Oh yeah, I've seen some of her work. It's amazing how much emotion she conveys with just a few lines.
It is, and Ramachandran proposes that Nadia's limited brain function, in a way, allowed her artistic module to really shine through. It's like her brain was this finely tuned instrument focused solely on artistic expression.
That's a fascinating idea.
Yeah.
So her brain wasn't bogged down by all those other cognitive processes that might interfere with creativity.
Exactly. And this law of isolation might explain why we find beauty in things like minimalist art or haiku poetry, where a few carefully chosen elements can evoke such a powerful response.
It's like those moments when a single brushstroke or a perfectly placed word can unlock a whole universe of emotion.
Yeah, exactly. Now, shifting gears a bit, another law Ramachandran discusses is our brain's aversion to coincidences.
An aversion to coincidences. What does that mean?
It's not that our brains don't like coincidences, but they prefer interpretations that minimize the role of chance. He illustrates this with an image that looks like a bunch of lines randomly intersecting. But to see that exact arrangement of lines in the real world, you'd have to be standing at a very specific vantage point. It's highly improbable.
So it's like a visual paradox.
Right. And our brains, always seeking to make sense of the world, prefer to interpret the image in a way that avoids attributing it to mere chance.
Okay, so we're constantly searching for patterns and explanations, even when they might not be there.
It seems so. It's like this deep-seated drive to find meaning, even if we have to create it ourselves.
But wouldn't that make us prone to seeing patterns where there are none? Like with conspiracy theories.
That's a good point. Our desire for meaning can definitely lead us astray, making us see connections that aren't really there. It's a delicate balance.
So we've got grouping, peak shift isolation, and the avoidance of coincidences. What other universal laws of aesthetics are we working with here?
Well, he also talks about symmetry.
Symmetry. I've always found symmetrical patterns so visually appealing. There's something inherently satisfying about them.
And this might be because symmetry is so prevalent in nature, you know? Think about flowers, butterflies, even the human body.
So our brains might be drawn to symmetrical objects because they could signal something important for survival or reproduction?
It's possible, and there's evidence that even babies show a preference for symmetrical patterns, suggesting it might be innate.
It's like we're hardwired for balance and order.
And finally, we come to metaphor.
Metaphor. I usually think of that in terms of language. How does it apply to visual art?
Ramachandran uses the example of a sandstone sculpture from Khajuraho. It depicts a nymph standing under a mango tree, and he points out the multiple layers of metaphor at play.
Okay, I see the nymph, the tree, the mangoes. What am I missing here?
Well, notice how the nymph's pose mirrors the curve of the tree branch, creating a visual link between the human form and the natural world. And then there are the ripe mangoes, which symbolize fertility, and their fullness visually echoes the nymph's breasts.
Ah, I see. It's like the artist is using visual cues to create a richer, more layered experience.
Exactly. And this use of visual metaphor taps into our brain's remarkable ability to connect seemingly unrelated concepts.
It's like those times when you look at a work of art and it just hits you on a gut level, you know? You can't always articulate why, but you feel this wave of emotions and associations.
It's almost like your subconscious is getting it before your conscious mind can catch up. Ramachandran suggests that the right hemisphere of the brain, which is more visual and spatial, might grasp the metaphor before the left hemisphere, which is more language-oriented, can put it into words.
That's so interesting. So the right brain is getting the feeling, and the left brain is trying to figure out what it all means.
That's a great way to put it. It really highlights this intricate dance between different parts of our brain.
It's amazing how much is going on beneath the surface of our awareness. All these intricate neural processes working together to shape our experience.
And that brings us to perhaps the most profound and elusive aspect of human cognition, the self.
The self. That mysterious entity that we all intuitively feel but can never quite grasp.
Ramachandran acknowledges how incredibly complex the self is, how it's shaped by our memories, perceptions, experiences, interactions with others. To illustrate this, he talks about a patient named Jason who had this very strange condition called telephone syndrome.
Telephone syndrome. I've never heard of that. What is it?
So, Jason had a head injury that left him in a semi-comatose state called akinetic mutism. Basically, his brain was stuck in pause mode. He couldn't initiate movement or speech. He was bedridden and unresponsive. But here's the bizarre part. If his father called him on the phone from another room, Jason would suddenly become fully conscious and engage in conversation.
Wow, really? He was only conscious when talking on the phone. That's incredible.
It really is. It suggests that different parts of Jason's brain, those involved in auditory and visual processing, were functioning at different levels of consciousness. And for some reason, talking on the phone allowed him to bypass whatever was causing his akinetic mutism.
It's like the phone acted as a bridge connecting those separate parts of his brain and allowing his consciousness to emerge.
It's a powerful example of how fragile and fragmented our sense of self can be, and how easily it can be disrupted by brain damage.
It makes you appreciate the incredible complexity of the brain, how all these different processes have to work together seamlessly for us to experience the world and ourselves in a coherent way.
It does. And this brings us to the challenge of understanding qualia, the subjective experience of consciousness. How do we explain what it feels like to see red or taste chocolate or feel pain?
The hard problem of consciousness. It's a question that's puzzled philosophers and scientists for centuries.
And Ramachandran doesn't shy away from these difficult questions. He even brings up Freud's idea of the unconscious, suggesting that modern technology might allow us to explore these concepts in ways we never thought possible.
So we might be able to peek into the hidden depths of the unconscious mind, a realm that was once considered inaccessible to scientific inquiry.
It's a really exciting prospect. To delve deeper into the self, Ramachandran outlines 5 key aspects that contribute to our sense of identity: unity, continuity, embodiment, privacy, and social embedding.
Okay, let's unpack those. What does he mean by unity?
Unity refers to the sense that we are a single coherent entity, despite the fact that our brains are constantly processing a massive amount of information. It's like an orchestra with different sections playing different instruments, but somehow it all comes together as a single harmonious piece.
Our brains are incredible at weaving together all those different streams of information into a unified experience of self.
Then there's continuity, the feeling that we are the same person over time, even though our bodies and experiences are constantly changing.
It's like that ship of Theseus paradox.
Okay.
If you gradually replace all the parts of a ship, is it still the same ship? Same with us, I guess. Our cells are constantly being replaced. Our memories change, yet we still feel like the same person.
Exactly. And that sense of continuity is essential for our sense of identity.
So what about embodiment? How does that play into our sense of self?
Embodiment is the sense that we are located within our bodies, that our bodies are a part of who we are. We experience the world through our senses, and we move and act through our physical forms.
Right. We're not just disembodied minds floating around. Our physicality is a core part of how we perceive ourselves.
Exactly. And then there's privacy, that sense that our thoughts and feelings are our own, that we have an inner world that's inaccessible to others.
It's like a secret garden within our minds, a place where we can retreat and just be alone with our thoughts.
And finally, there's social embedding, that sense that we are part of a larger social network, and that our sense of self is shaped by our relationships with others.
So we define ourselves in relation to others as parents, children, friends, colleagues, members of a community.
Precisely. And what Ramachandran points out is that all of these aspects of the self can be disrupted in various neurological and psychiatric conditions.
So our sense of self isn't as stable as we might think. It's vulnerable to these disruptions.
It is. It's more like a dynamic interplay of brain processes, a delicate balancing act that can be thrown off kilter.
I imagine those disruptions can lead to some pretty strange and unsettling experiences.
Yeah.
Does Ramachandran give any specific examples?
Oh, he does. And he starts with a condition called apotemnophilia.
The potemnophilia. What's that?
It's where individuals desire the amputation of a healthy limb.
Whoa. Why would someone want to amputate a perfectly healthy limb?
That's the question, isn't it? And Ramachandran challenges the typical psychological explanations, suggesting that it might actually have a neurological basis.
So it's not just a psychological quirk or a desire for attention.
He proposes that it might be related to a mismatch between the brain's body image and the actual body. It's like the brain's internal representation of the body doesn't match the physical reality, leading to a sense of alienation from the limb.
Their brain is rejecting a part of their own body.
It's a strange and somewhat disturbing phenomenon, but it highlights how our brains strive for consistency and how a mismatch can lead to some pretty extreme behaviors.
It's like our brains are saying, this can't be right, this limb doesn't belong to me.
And this concept of mismatch aversion actually plays a big role in many of the conditions Ramachandran discusses. Our brains really hate inconsistencies and will go to great lengths to resolve them, even if it means constructing elaborate delusions.
It's fascinating and a little unsettling to think about.
It is. And it brings us to another mind-bending phenomenon, out-of-body experiences.
Out-of-body experiences. Have you ever had one?
I haven't personally, but they're incredibly intriguing from a neuroscientific perspective. Ramachandran suggests that they might be linked to disturbances in the mirror neuron system and frontal lobe inhibition.
Oh yeah, mirror neurons. Those mind-reading cells that allow us to simulate other people's actions and perspectives.
Right. And Ramachandran proposes that in out-of-body experiences, this mirroring process might go a bit haywire, leading to the feeling of being detached from one's own body.
It's like your consciousness is floating outside of your physical boundaries.
That's one way to think about it. He even mentions a case of a patient who experienced a phantom twin during an out-of-body experience. It's as if his brain created a duplicate of himself that he was observing from outside his own body.
That's wild. It makes you wonder about the very nature of the self and how it can be split or projected like that.
It's a question that continues to fascinate scientists and philosophers alike. But to help us understand this better, Ramachandran points to the role of the left hemisphere in constructing a coherent narrative of the self.
So our left brain is like the storyteller of our lives, always trying to weave together a consistent narrative, even if it means filling in the gaps or embellishing the facts a bit.
Exactly. And this tendency to confabulate, to smooth over inconsistencies and create a seamless story, might be connected to another phenomenon. Ramachandran discusses anosognosia.
Anosognosia, what's that?
It's a condition where patients deny their own paralysis. For example, someone might be completely paralyzed on one side of their body, but insist that they can move just fine.
Wow, how is that even possible?
It's really strange. Ramachandran suggests that it might be the brain's attempt to maintain a coherent body image, even in the face of conflicting sensory information.
So their brain is basically saying, nope, this can't be true. I must still be able to move, even though their body is telling them otherwise.
That's the idea. And they might even come up with these elaborate explanations to justify their paralysis.
It's like their brains are building these elaborate defense mechanisms to protect their sense of self from a very harsh reality.
Precisely. And this illustrates how crucial our sense of self is for our well-being. Our brains go to great lengths to preserve it.
It's almost like our sense of self is this fragile ecosystem that can be easily disrupted.
That's a good analogy. And now we come to this fascinating interplay between perception, emotion, and the self. Ramachandran explores this through two very intriguing conditions, prosopagnosia and Capgras syndrome.
Prosopagnosia, that's face blindness, right? Where people can see faces, but they can't recognize them.
That's right. And Capgras syndrome is kind of the opposite. People with Capgras can recognize faces, but they believe that their loved ones have been replaced by imposters.
Wait, what? That's so creepy. Why would they think that?
It's a truly bizarre delusion. But Ramachandran suggests that both conditions involve disruptions in the pathways that connect face recognition to emotional processing.
So in prosopagnosia, the wires are crossed, and they see the face but don't feel the emotional connection. And in Capgras, the emotional response is there, but the conscious recognition is messed up, leading to this strange belief that the person must be an imposter.
Exactly. It's like two sides of the same coin, and it emphasizes how intricately our brains weave together perception, emotion, and the self.
This is all so mind-blowing. Our brains are capable of some really strange things.
They are. But as Ramachandran points out, understanding the brain doesn't diminish the wonder of human experience. It actually enhances it, and there's still so much more to explore.
Welcome back to our deep dive into the telltale brain. Our brains are so complex and capable of such incredible and sometimes bizarre things.
They really are. And as we were discussing before, when those intricate processes get disrupted, it can lead to some pretty fascinating and sometimes unsettling experiences, like with prosopagnosia and Capgras syndrome, where the connection between facial recognition and emotion goes awry.
Right. It's like in prosopagnosia, the wires get crossed and you see the face, but don't feel that spark of recognition. And in Capgras, the emotional response is there, but the conscious recognition is off, leading to that eerie feeling that the person you're looking at must be an imposter.
Exactly. It really highlights how our brains are constantly working to make sense of the world, striving for consistency between our perceptions and emotions. When those two things don't align, it can lead to some pretty strange experiences.
It makes you realize how much we take for granted this idea that our experience of reality is accurate and stable. But it's actually a very delicate construction.
It is. And speaking of delicate constructions, another intriguing phenomenon that Ramachandran explores is panic attacks. Those sudden waves of intense fear and anxiety that can seemingly come out of nowhere.
Panic attacks can be absolutely terrifying. I've heard they can be so debilitating.
Absolutely. It's like a physical and emotional earthquake shaking your whole sense of being.
Do we know what causes them? Is it purely psychological, or is there a neurological component as well?
While the exact causes are still being investigated, Ramachandran offers a fascinating neurological perspective. He proposes that panic attacks might be triggered by mini seizures in the brain, specifically in those areas involved in processing emotions, like the amygdala and its connections to the hypothalamus.
So it's like a sudden surge of electrical activity in the brain's fear circuitry.
That's one way to think about it. And these mini seizures could lead to that cascade of physiological responses that we associate with panic attacks. The rapid heartbeat, sweating, shortness of breath, that overwhelming sense of dread.
But if there's no real danger present, why would the brain trigger such an intense fear response? It seems counterproductive.
That's where the brain's aversion to discrepancy comes in again. You know how we were talking about how the brain hates inconsistencies and tries to explain them away?
All right, our brains are like little detectives constantly trying to make sense of the world.
Exactly. So in a panic attack, there's this mismatch between the neutral external environment and the intense internal physiological arousal. Your body is screaming danger, but your senses are telling you everything is fine.
So the brain trying to reconcile this discrepancy might misinterpret the physiological arousal as a sign of imminent threat, even though there's no logical reason for it.
That's the idea. It's like a false alarm going off in your brain, triggering that fight or flight response when there's no actual fire.
It's a pretty terrifying thought. It makes you realize how powerful our brains are, how they can create these really intense emotional experiences, even when there's no real external threat.
It's a humbling realization for sure. And this brings us to another crucial aspect of human cognition that Ramachandran delves into memory. Specifically, he discusses the famous case of patient.
Yeah. He's the man who had parts of his brain removed to treat his epilepsy, right?
That's right. And as a result of the surgery, HM developed severe anterograde amnesia. He could no longer form new long-term memories.
So he was stuck in the past, unable to create new memories of his experiences.
In a sense, yes. But what's remarkable about HM's case is that even with this profound memory impairment, he still had a sense of self. He knew who he was, he could hold conversations, he could interact with the world, even though he couldn't remember those interactions moments later.
So even without the ability to form new memories, his sense of self remained intact. That's incredible. It suggests that our sense of self isn't entirely dependent on our memories.
Precisely. It points to a deeper, more fundamental aspect of the self that goes beyond our individual memories.
That's fascinating. It's like our sense of self is a flame that continues to burn, even as the fuel of our memories flickers and fades.
That's a beautiful way to put it. And to further explore this, Ramachandran highlights another key brain area that's crucial for our sense of self, the anterior cingulate.
The anterior cingulate, doesn't that have something to do with emotions?
It does. It's part of the limbic system, which is often referred to as the emotional center of the brain. But the anterior cingulate is also involved in a wide range of cognitive functions, including decision-making, error detection, and even our sense of free will.
Free will, that's a topic that's been debated for centuries. Is there really such a thing as free will, or are we just puppets of our biology and our environment?
It's a question that might not have a definitive answer. But Ramachandran's insights into the anterior cingulate offer a really interesting perspective. He suggests that damage to this area can actually impair our sense of agency, the feeling that we are in control of our actions.
So if our brains are the drivers, the anterior cingulate is the steering wheel.
That's a great way to think about it. And when the anterior cingulate is damaged, it's like we've lost control of the vehicle. Our actions feel less like our own and more like something happening to us.
It's a little unsettling to think about, but it's also fascinating how much we're learning about the brain and how it shapes our experience of the world and ourselves.
It really is. And as Ramachandran emphasizes, understanding the brain doesn't diminish the wonder of human experience, it actually enhances it.
It's like the more we learn about the brain, the more amazing it becomes.
Yeah.
It's this incredibly complex organ full of mysteries and secrets just waiting to be unlocked.
Absolutely. And this deep dive into the telltale brain has given us a glimpse into just how remarkable the human mind is, from the way we perceive illusions to the mysteries of consciousness and self.
It's been an incredible journey. And for all of you listening out there, I encourage you to keep exploring, keep questioning, and keep marveling at the extraordinary capabilities of your own minds.
And as you go about your day, take a moment to appreciate those everyday miracles. The way you effortlessly navigate the world, the spark of insight that leads to a new idea, the flood of emotions that a piece of music evokes. Each of these experiences is a testament to the power and wonder of the human brain.
We're all walking around with these vast universes inside our heads, universes that are just waiting to be explored. So keep those minds curious, and we'll see you on our next deep dive.